Okay, welcome back. Today we're doing Leetcode problem 11, container with the most water. Um, I've been out with food poisoning for a very long time now, and it wasn't fun. So don't eat fresh vegetables when you're in Mexico. Anyways, okay, so you're given an integer array, height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and I height of I. Find two lines that together with the x-axis form a container such that the container contains the most water. Honestly, let's just look at the picture. It's kind of a confusing problem when they write it out like that, but if you just look at the picture, it makes it a lot clearer. So basically you're given a list called height, and it's a list of integers, and they want you to find the largest area between any 2 points inside that list. So what is area, right? It's width times height. And so in this example, the largest area is 49. And the reason that this is highlighted in the way that it is because since the largest area is created from this point 8, which is index 1, and this point 7, which is at the end of the list, you would have a width of 7, right? 1, 2, 3, 4, 5, 6, 7. That's the bottom. And a height of 7. The reason the height is 7 is because even though we're comparing 8 and 7, think of the bucket like a two-dimensional bucket like you're seeing now. If you fill this up with water, it can't go any further than 7 because it would just spill over, right? You can't fill it up to 8. It would spill over to the right side here, right? So if you just create a bucket like in your home and you cut off one side of the wall, I guess a two-dimensional bucket, the water is going to spill out, right? So the idea here is you are going to be taking the smaller of the two values when you're considering area. And so let's talk about the approach we're going to take. I wrote out a little bit here. It's going to be a two-pointer approach. That's at least how I'm going to do it, right? Where you start at 0 in the end of the list, and you're going to squeeze down to the middle. And every time when you're considering 2 points, you're going to take the smaller of the two heights, right? Because you can't calculate an area with the larger of the two heights. That's impossible. The water would spill over. And let's look at this beautiful drawing that I made over here, right, for this example. Because the question that we're going to have eventually is, okay, now that I've calculated the area, right, and the way we do that is by taking, like I said earlier, the minimum of the two heights and multiplying it by the width. So this here, the min of heights at P1 and heights at P2 would be 1, right? 1 and 10, the smaller of the two is 1. That's our height. But what is our width? Our width is just the difference in distance between P1 and P2. 1, 2, 3, 4, 5, right? So it'd be 5. That's our current area. 1 times 5. But now, which direction do we move in, right? Do we move P1 up or do we move P2 down? Well, we want to move P1 up, and the reason is because it's the smaller of the two values. Again, the reason we do that is because you want to always maintain the possibility that you're going to see a larger height. If we removed P2, we're taking out the possibility of ever calculating an area that would be as tall or taller than 10. So let's look at this visualization here, right? This is actually, this portion here, this is the largest area in this example, right? And this is what? It would be between this 10 and this 10. 1, 2, 3. So the max area here would be 30. If we moved this 10 down in our first iteration, when we were calculating the area, we saw that it was 5. And we moved P2 down, instead of P1 up, we would no longer consider this 10 here, and we would lose the possibility or the potential of calculating a larger area. So that's why you want to move the smaller of the two heights down towards the middle, or up towards the middle. It depends if it's P1 or P2. So let's go ahead and code this up. Import math here just because we're gonna do some. We're gonna use a global value and set it to like negative infinity. But here, let's do some error checking. If the length of the list is less than 2, then just return 0, right? Because if it's 1, if there's only one value in here, there is no width. There is no width, so there's nothing to actually calculate. And if there's nothing in here, well then there's no area. So let's say max area is equal to, let's set it to first negative math dot infinity, and P1, P2 is 0, and the length of our levels minus 1, right? P1 is 0, starts here. P2 is our last index in the list. And while P1 is less than P2, this is what's going to control our loop. Our current area is going to be composed of our width times height. Let's calculate the height. Right? Height is equal to the minimum of levels at P1 and levels at P2. It's the smaller of the two heights. That's our height. That's the maximum that we can fill our bucket up to. Now, what's the width of the height? Sorry, what's the width of our container? Width is equal to P2 minus P1, right? 1, 2, 3, 4, 5, 6. Yes, width is P2 minus P1. And our current area is equal to width times height. Once we've calculated our current area, what we do is we compare it to the max area that we have. So max area is equal to the maximum of itself in our current area. Now we have to decide which direction to move. Actually, it's not which direction. Decide which pointer to move, right? If levels at P1 is less than levels at P2, that means that the pointer is smaller at P1. It points to a smaller height than P2. Remember how we always want to maintain the potential for calculating a larger area in the future? That's why we move the smaller of the two up. So P1 is incremented once. Else, that means that P2 is the smaller of the two values, and we decrement it, yeah? And then here, you can return the max area. At this point, you would be done with this loop, and then you can go ahead and return that. Let's run it and see if it works. Nice. Very nice. Okay. So for this problem, we are, let's see, runtime wise, we're using 2 pointers. We're squeezing down to the middle, and we're just going through the list one time. So that's O of n. So this would take O of n to run, and then space wise, it's just, you're using 2 variables, so it's actually O of 1. It doesn't change, you're just using, it's consistent, right? You're just using an area and it's a couple variables for P1 and P2. So it's O of 1. So yeah. Thank you.